Okay, good morning to all of you. Today we are having our resource person, Dr. Chandan Kumar Jha. So I am going to introduce about him. Dr. Chandan Kumar Jha is working as an assistant professor, Department of EC, IIT Bhagalpur. Formerly, he was an assistant professor at Kalinga Institute of Industrial Technology, KIT, Bhubaneswar. He completed his PhD degree in biomedical signal analysis from IIT Patna in 2019. He did ME in microwave engineering from Birla Institute of Technology, Mishra Ranchi in 2012 and BTech in electronics in communication engineering from West Bengal University of Technology, Kolkata in 2010. He has published many international peer-reviewed journals, conference papers, and book chapters. His research interests include biomedical signal and image analysis, artificial intelligence, deep learning, and machine learning. Over to you, sir.
So thank you, dear sir, for nice introduction. So, on this second day of this FDP, I just want to give the complete detail of the ECG signal analysis, and I also included some demonstration and implementation based on the MATLAB code. And you can also implement it on the Python. So based on the, because Python is usually used here, means in today's scenario, widely. So you can also prefer to use Python. But here I have just included demonstration related to the MATLAB. Okay. So basically, the title is ECG signal analysis. Means ECG, as I think you all of you know about the ECG. What is ECG? Anyone can tell me?
Electrocardiogram.
Electrocardiogram. So basically, ECG is the signal related to our heart muscles. Means it is the stimulation of the muscles of the heart it generates. Okay, and if you just record that signal, then that will be called the ECG. And we have to just, in this lecture, I will just tell you how you can just analyze ECG signal. Okay. So firstly, I just show you what is the content of this presentation. Firstly, I will just introduce about the different related topics related to the ECG signal analysis. After that, ECG signal acquisition, how you can acquire the ECG signal. After that, artifacts in ECG signal. What are the different artifacts can exist in the ECG signal? And after the artifacts, there is the analysis part. Means you have to do analysis, and the analysis part will include denoising, compression, and classification. The third point I included here, fourth point, HF and the LF noise removal of ECG signal. How you can just remove the high frequency and low frequency noises which are associated with the ECG signal due to the different reasons. I will also explore what are the different reasons due to which artifacts exist in ECG signal. And third, after that, wavelet-based time frequency analysis. I will discuss about how you can perform the wavelet-based time frequency analysis of ECG signal, and how you can just use the AI for automated heart disease detection using the ECG signal. Because if you just go to the hospital, then you will just see a 12-lead electrocardiograph is there. And using that electrocardiograph, cardiologist just record the ECG signal, and in that electrocardiograph, there is the AI, existing AI, which just analyze the ECG signal, and based on the AI, they will just say, means the machine says, following person's ECG is problematic or not, means it is disease or not. So AI is there. That's why AI for automated heart disease detection are included. How it can be performed. After that, one technique which I just published in 2020, TQWT and SVM based automated arrhythmia detection technique. I will elaborate that how I have just developed the methodology to just detect the arrhythmia. I will also tell you what is arrhythmia. So I will include all those topics. After that, I will just conclude, and after the conclusion, I will just show you how you can just do the coding. Simple basic coding from the 0 point, how you can just take the data and how you can perform the coding. Okay, and some references. for which I have just taken the content after that. So firstly, what is the cardiovascular disease? So in I think 1 month or 2 months earlier, you just heard about the कौन Gupta था? Raju Gupta. He passed away. Raju Srivastava. Yes, Raju Srivastava passed away due to the cardiac arrest or cardiac failure. And after that, one more news regarding the KK. KK was also died due to the sudden cardiac arrest during the performance at some in Kolkata. So the cardiovascular disease are increasing exponentially in nowadays, and as per the World Health Organization, it is the leading cause of it. And if you just see the statistics, in 2019, about 17.9 million people died due to the cardiovascular diseases, and it just constitutes 32% of the all global death. So you can just assume how this just increasing exponentially. And if we just say what is the cardiovascular disease, then you can easily define it as the disease related to our heart and the blood vessels related to it. So it may be the different kinds of types. Okay, it may be the different types because it may be the problem of the blood vessels, it may be the problem of the heart muscles, and due to that abnormality, the functionality of the heart will affect it. So all these can included in the CVDs, cardiovascular diseases. And if we just want to control, if we just want to manage the risk, then early detection is necessary. Okay, so first you have to early detect the disease so that you can just consult the cardiologist and take medications and whatever the exercise or some suggestions the cardiologist will take, you can just do. So early detection of CVD is essential for risk management, and by the for the early detection, you can use the ECG signal by some portable devices, wearable devices, so that nowadays some Apple watch of that you can just you can I think many of you have just used also. They just there's a single node device. They can just collect the pulse here, and they can predict the heart rate. And based on the analysis of the heart rate, heart rate variability analysis, the AI-based machine, this is also include the AI to tell about whether the heart rate is normal or abnormal, whether you have to just concern about that, you have to just take care of about that. Okay. So all these devices are developing in today's scenario. Okay. Now here I have included the introduction of the ECG, what is ECG, and a normal heart cycle. So as I already told you, what is ECG? It is the recording of our electrical activity using the muscles, and we can just use to record it using different electrodes based on our different body positions. So there are different positions by which we can just put the electrodes, and by those electrodes we can just record the ECG. Okay, so I will explain how you can just record. But if you just see here a normal heart cycle, then it has some components are mentioned here: P wave, QR complex, T wave, and there is some certain time interval also: PR interval, PR segment, QR complex, ST segment, QT segment. So all the components have its significance in terms of the cardiology. Cardiologists use all these components to detect what kind of different kinds of diseases are there by the analysis of all this amplitude-based features and time-based features, as well as morphology. Okay, morphology is shape. So based on the shape, time, and amplitude, cardiologists can easily predict what kind of disease are there. But here our motive is to develop the machine, AI-based machine, AI-based device, so that they can predict the disease and we can just manage the risk. Okay, so that is the motive. As an engineer, we have the motive. Okay, so this is the introduction, and these are the different components of ECG, and here you can just if we just say tell you what is the peak amplitude, so you can just see here R is the maximum amplitude. So that is called
पॉइंटर नहीं है सर इसका मार्कर दे सकता है मार्कर उसको ठीक रहेगा
तो यहाँ पे means here you can just see the maximum amplitude is R. So it has the highest amplitude. In ECG, maximum amplitude is R peak. So R is the point where ECG has maximum amplitude. So next is here regarding the peak amplitude. What is the maximum? In generally, the peak amplitude is about 1 millivolt. And if we just concerned about the frequency, then the frequency range of the ECG signal is 0.05 to 100 Hz. So within that frequency interval, it will lie. And peak amplitude is 1 millivolt. And here you, if you have just visited hospitals, then you can just see that cardiologist just put the electrodes somewhere on the chest or limbs. So here, without any penetrating our body part, they can record the ECG. So it will be non-invasive, obviously. Means they don't need any surgery. So it is a non-invasive method. So that's why it is most preferable. Okay. So it is used as a non-invasive clinical tool to detect different heart diseases. And regarding the use of the ECG, a cardiologist uses ECG to interpret abnormalities of her different kinds of abnormalities. It may be the arrhythmia, it may be the myocardial infarction. Another point is heart rate and the rhythm of the heart rates. They can predict what is the heart rate by counting the number of heartbeats per minute, is beat per minute BPM. And after that, using the ECG, they can also predict the size and position of our heart chamber. Means it has the bigger size or some abnormalities are there in the, related to the size of the chambers. Okay, and they can also detect about the conduction, electrical conduction system of our heart. Means it is affected by some abnormalities or not. Because if there is the signal, there is the potential. Because you know that signal is nothing but the potential. As if you will just study the electronics, the signal is nothing but the potential. And in terms of the biological term, there is the action potential. Means potential generated by our heart muscles. Means if we just put two electrodes across a heart muscle, then it will generate some potential. That potential is called action potential. So here, so action potential is generated. We can just say action potential is generated by some electrical conduction system. So heart is also an electrical conduction system that can generate the potential, and we can just record that action potential, and that recording is called ECG. Okay, because so here I have just included the picture of heart, and you can just see here there is the four chamber: left atrium, right atrium, okay, right ventricle, left ventricle. And regarding the functionality of heart,